Hello class, today we are going to discuss chapter 6 periodic table. So the subtopic is 6.1 classification of elements. The learning outcome will be specify periods, groups and blocks in the periodic table and reduce the position of elements in the periodic table from the electronic configuration. As we know, in periodic table, elements can be arranged in order of increasing proton number. A vertical column is called a group and the horizontal row is known as period. Period. So how to determine period is based on the number of shell or the largest principal quantum number in the electronic configuration. A horizontal row in the periodic table is known as period, and period is numbered from 1 to 7. And how to determine block? Block can be determined by the highest energy of orbital occupied by valence electrons. There are 4 main blocks in periodic table, which is classified as S, P, D, and F block. Okay, so for S block, it involves elements from group 1 and group 2. So the filling of the valence electrons, okay, will end with an S1 or an S2. For example, we have sodium. So the electronic configuration is 1s2, 2s2, 2p6 and 3s1. So the highest energy of orbital filled with valence electron is 3s. So sodium is in S block. Okay, or we can have calcium. Okay, so the calcium end with 4s2. So the highest energy of orbital in calcium is 4s. So calcium is also in S block. And then we have P block. So P block involve element from group 13 to group 18. So normally for P block, the electronic configuration will end with an S2 and P1, 2 and S2 and P6. So for example, aluminium. So for aluminium, the valence electron is 3s2, 3p1. So this is P block and then it has 3 valence electrons. Okay, so for D block, it will involve elements from group 3 to group 12, which are also known as transition elements. So the electrons, the filling of valence electron will involve ns and n-1d orbital. The electronic configuration normally ends with ns2, n-1d1, 2 and s2, n-1d10. So for example, the vanadium atom, so it ends with 3d3, 4s2. So this is a D block element. And finally, for our F block, so for your F block, normally you will end with the 4F to 5F. So now we see how to determine group. So the group is based on the number of valence electrons. So for S and D block, the group number is equal to the number of valence electrons. And for P block, the group number is equal to the number of valence electrons plus 10. Let's look at example 1. Without referring to periodic table, classify the below elements to the period, group, and log. So we have potassium, calcium, and titanium. So remember, to determine period, we will look at the number of shell or the largest principal quantum number. And to determine the block, it will be based on the highest energy of orbital. And group is based on the number of valence electrons. So after you determine the block, if we know the element is from S block or D block, the group number is equal to the number of valence electrons. Or let's say if the element is in P block, then the group number will be equal to number of valence electrons plus 10. So first one, potassium has 19 electrons. So first thing you need to do is write the electronic configuration for potassium, which is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. So first thing, let's determine the period. So what is the highest principal quantum number in the electronic configuration? The answer is 4. So we has the highest n, which is equal to 4. So we know the period is equal to 4. And next one, let's determine the block. So the highest energy orbital is also 4s. So we know potassium is in S block. And based on the 4s, okay, there's one electron field in the 4s. Okay, so we know the outermost shell. Okay, we know the outermost shell is 4. So there are one electron. Okay, there are one electron in the outermost shell, which is, so we can know the group is equal to 1. So our answer is period 4, S block, and group 1. So for question B, chlorine. Chlorine has 70 electrons. So the electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3p5. So first thing, we want to determine the period. So which one is the highest? What is the highest principal quantum number in the electronic configuration? So the highest n is equal to 3. So we know the period for chlorine is 3. And how about the block? So the highest energy orbital is 3p. So we know chlorine is in P block. So for P block, the valence electronic configuration will be 3s2, 3p5. Okay, because the outermost shell is 3, and based on the outermost shell 3, we have 7 valence electrons. So from here, we can determine the group of chlorine. So 7 valence electron plus 10, so we will get the answer for chlorine is period 3, P block, and group 17. And last one, titanium. So titanium, okay, we write down the electronic configuration for titanium. So we're going to determine the period. So what is the highest principal quantum number? The highest principal quantum number is equal to 4. Okay, it's equal to 4. And then now we're going to determine the block. Okay, so we know titanium is in period 4. And how about the block? So the block, the highest energy of orbital, okay, the highest energy orbital is 3D. Okay, 3D. So titanium is in D block. So the valence electronic configuration for D block will be NS2 and D2. Okay, and okay, for S2, 3D2. So the valence electronic configuration for titanium is 4s2, 3d2. So we can see there are 4 valence electron on the valence electronic configuration. So titanium is in D block, so the group will be equal to the number of valence electron. So we get the answer period 4, D block and group 4. Okay, so that's all for my video. Thank you for watching.